Section 2.4 exercise 37. Here we're given that y equals the square root of x plus 1 over x, and we're asked to use a computer algebra system, a CAS computer algebra system, to find the derivative and then graph the function. Well, the function and its derivative. Now it's actually probably, the graph is probably easier done in Desmos. CAS will use Sage Cell, which is actually an application that is running Sage Math. And so we'll go to Sage Math here, and to get this to work, it's really not too bad. There's definitely some learning curve here, but I want a symbolic variable. Let's see, can I make this bigger? No, I don't know how to make it bigger. So at any rate, there's I first tell I want a symbolic variable with the VAR, and I put the X in quotations. If I needed more than one symbolic variable to start with, I would just put a comma in the other variable, for instance, like if I needed an A or something like that. Then here I define f. I didn't write it as f of x, though that can be done in certain situations, but for this, all I need to do is say f is the square root of x plus 1 divided by x. So there I'm just defining the function. Now here I used f, I said fp equals, and I said that for fp, because of f prime, and I said f, so I took the original function here and I said dot diff, and so it's the derivative or differentiated dot diff of x, right, with respect to what? You need to tell it with respect to what, and so I told it with respect to x, and then and assigned it to this fp. So then I showed fp. We'll look at that, and then I showed and it looked a little complicated, so there's this nice command called simplify, and I put that around the fp, and I said show that simplified. Well, we'll see that didn't help any, but you can also expand things, like if you had a product and you wanted to multiply things out and that kind of thing, you can say expand. And so here I expand first and then I simplify and I show it. And to run all this, I just hit evaluate. And so here is the original answer, the derivative, and it's kind of complicated to look at and so forth, but there it is. And then I ask it to simplify. Well, actually it didn't. It just left it the way it was. But then I said, well, hey, expand it first and then simplify, and now it does look much, much better. We now can get it down to this negative 1 over 2x squared times square root of 1 plus 1 over x plus 1. Now you could get a common denominator in this thing and you would get back to your x plus 1 over x underneath the square root. But it's kind of funny. It's not clear why, if in this part of the simplify it left it that, as x plus 1 over x, why it changed it here, don't know, but that's one of the things with technology. But there's our answer. But if I'm going to graph it, and I just want to graph the derivative, and I don't necessarily need to know its formula in the graph, well, in that case, then I probably want to use Desmos, and here I put our function into Desmos and it plotted it in the red. I don't know if I can, yeah, I don't know if I can, here, can I move that around? No. So my recording thing is sitting right over the graph. Yeah, I just can't reach it with the recording button sitting there. But anyway, I think you can see that pretty well. So, oops, gotta watch out. Can't get the pen too close. So, you know, we have our function in red here, and then the derivative. And, you know, remember the derivative is the slope of the tangent line, and so, you know, what you see here is that in both cases, as we move out to the right or out to the left, the function is leveling off, and so the derivative or the slope of the tangent line should be going to 0, and that's what we see with our blue line. And if we look in the middle more, we see very, very steep slopes, and they're both negative, and so we should be seeing the derivative heading down toward very negative numbers, and it is. And they wanted you to look at where the function was 0, but actually, let's see, this function, what happens, I guess, as x is negative from the left, this square root from the left of -1, this square root is defined, because like if I put -2 in there, I'll get a -1 over a -2, which is a half. Take the square root of a half. So that's defined, so that's coming in there like that. And it's heading to 0, you know, and we can see, you know, right at 0 then. But the problem is the function isn't defined on both sides of x equal -1, and so we don't really get to see the behavior that they're asking us to look for in those problems. But nonetheless, we can see that the blue, the derivative values do match what's going on with the slopes of our original function in red. So again, you can use Sage Cell to calculate derivatives quite easily. You know, I mean, it didn't take but 3 lines here to calculate the derivative of our function. Well, I had a 4th one to see what it was, and I needed to say show or display or print or something like that to see it. I like show, it makes it look the best. And, you know, but so we can get Sage to calculate derivatives for us just fine. It may or may not simplify it very nicely for us, but there we go. There is number 37.